Welcome back. I hope you had a great lunch, good conversations. We have two sessions this afternoon. So our first session has to do with projects involving material science collaborations and ancient materials. So we have material and acoustic studies of historic musical instruments, which is up there in front of you. I don't need to read that. Okay, we have Mark Rau from music, and we have Will Broadhead from history. They'll each give presentations on their work. They're joined by their collaborators. So Mark's collaborating with Benjamin Sabatini from Material Science and Engineering, and Jared Katz from the Museum of Fine Arts. And then Will's collaborating with Mike Tarkanian, also from Material Science and Engineering. So we'll hear their two presentations, and then they'll be joined by Betsy Williams, who's actually joining us from the Museum of Fine Arts to moderate the conversation. So I'll be back with the audience Q&A part. But Mark, come on up here.
Thank you, Kirill, and thank you, everyone else. The team of me, Jared, and Benjamin, we just want to briefly get to our next slide and just briefly introduce our background, since it's a bit varied. My PhD was in music technology, and I am a guitarist, and I studied the acoustics and measurement modeling of guitars primarily.
Sure. My background is actually in material science and thermodynamics from the University of Oxford, where I basically modeled ancient alloys, which is kind of a strange fit for the project, but.
And hi, everyone. Yeah, my name's Jared Katz. I'm the Poppolato Curator of Musical Instruments at the MFA. My PhD is actually in anthropology, and I am an archaeologist by training. I specialize in ancient musical practices, in particular ancient American musical practices, iconography, and replicating ancient instruments.
So this project was kind of a perfect storm of us getting to Boston around the same time, or some of us, and MITHIC being created. So yeah, we're a SHAS Plus Connectivity Fund project. And we teamed up with the Museum of Fine Arts in Boston. So they have an incredible instrument collection. And as a musician, I go to these museums and I see the instruments and I always want to play them and hear them. But they never let you. So we want to try to work on ways to measure them and model them so that we can actually hear them and have them played. So we're doing that using CT scanning, vibration acoustic measurements, and simulations. So a brief introduction to the collection.
Great. Yeah, so I just wanted to quickly talk about the MFA's amazing collection of instruments. So the collection was actually founded in 1917, and it was amassed by a musicologist in the UK named Francis Galpin, who was fascinated from instruments all over the world. And in particular, he was really interested in how instruments worked. And so he built this collection of over 600 instruments from 6 continents, spanning thousands of years. And a local Boston businessman, tragically, his daughter passed away in the sinking of the Lusitania, and he bought this collection of instruments from Francis Galpin and donated it to the MFA in 1917. So this was the founding of our collection. And you can see I included this next quote by Bessarabov from his 1941 work. And this is really the work where he kind of pioneered the term organology, or really popularized it. And it was talking about our collection at the MFA. And organology is really the study of instruments as engineering objects, and to understand scientifically how they work, how they operate, the acoustics behind them. And so this project is fantastic for this collection because really we were designed to be an organological laboratory. And that's what we're continuing the legacy of this work. So right now we have around 1,450 instruments in the collection from all 6 continents. You can see a breakdown by percentage at the bottom of the slide there. But yeah, they span from around 1550 BCE all the way through 2020. So it's a really great resource. I encourage you all to come and see it, and we're excited to be studying it.
Right, so skipping now, I guess, to the analyses part. And the 3 images you see there, the one on the far left is from the museum's catalog. That is Paracas whistle. Everything is labeled, but I won't discuss those in great detail. The one in the center is a CT scan of it. And the lines around it are basically what we call regions of interest, where you define like exactly what you want to look at, and you can focus on it and build like higher resolution images that way. And the one on the right is one of our slip cast recreations that I'm making in the lab with some Europs. It is as close as we can possibly get it to the original, so including its core, which is very important for how it sounds. Click. Sorry. And that's just a view of the longitudinal cuts, which are up and down, and that's the axial cut that goes all the way through. So basically, you can see everything that's inside, the pores, the imperfections, the density differences especially. And on this one, you can see towards the midsection, a little bit lower, there's a sort of a crease there, which is actually where it had broken at some point or cracked. That will come up later. Okay. Yes, next slide. The image on the left is when we installed the CT scanner at the museum, which was very exciting because we got to push it through the galleries. The room where we work is just beyond this area, which is the Greek and Roman collection. The one next to it, that's another musical instrument. It's shaped like a fish, and I have a sort of prop of that I'd like to show people at the end. We've managed to recreate it, and it does play, along with the whistle that you saw earlier, which also does work. Click. Right, so here we see the axial cut, and just on the far right, the fish spinning. And as you can see, as it comes around, you can see all the internal imperfections and exactly what where the tone holes are made and how that might affect the sound. It's really important for us to get that internal information because that's how we can recreate the sound as close as we can to the originals.
So there's a number of different elements that we're hoping to gain from this research and this work. The first is that we're gaining invaluable information in how the instruments were actually made, the technology used by ancient makers when they're creating these instruments. So for example, in the bottom left there, you can see the Paracas whistle again, and you can see these coils of density. So this instrument is actually made using a coiling technique. In other instruments, we can see that they're mold made, and in other instruments, we can see exactly how they're tuning them. So it's really great for our curatorial records to understand how these instruments were being fabricated. Next, it helps us a lot when we're making mounts or thinking about how to pack and transport these instruments when we lend them for other exhibitions. So for example, on the far right, you can see the Paracas whistle again, and this is a porosity scan where we can see these micro fractures and we can see weaker sections of the instrument. So when our mount making team is designing a mount, we know which weak spots to avoid when we're gripping it to make sure that we're protecting the instrument as best as possible. So this is really just making it much more effective to us to engage in practical day-to-day museum practices. And then finally, in terms of organology, we're really fascinated by studying measurements of everything. Whatever we can measure, we're going to measure it. That's just what we do in organology. And so these X-rays allow us to get really accurate measurements, even all the way down ducts and tubes within instruments, things that you couldn't measure previously. So this allows us to see how instruments over time are changing in really minute ways as practices are being developed, honed further.
Okay, I should also just mention if it wasn't clear. So the instruments, the reason we have the CT scanner in the museum is that the instruments are very fragile and generally just can't be taken out of the museum. So that gets to the other side of when we're making, if we say study these CT scans and make recreations, we want to verify that they actually sound correct. But we can't always just play them, so we have to use non-destructive vibration and acoustic measurements. So here's an example of two dance master fiddles being measured. So they're very, very small violins. So there's a very tiny hammer that strikes the instrument, which is essentially exciting all frequencies at once. And then it's being measured with a laser Doppler vibrometer. So this is a very detailed way to capture the acoustic response of the instrument, which we can then use to validate our models. And also, we can use it in kind of real-time simulations if we're trying to make a digital recreation of the instrument. And then here, yeah, so that's the type of measurement you might do with something like a stringed instrument. If you have a wind instrument, you have different physics that you're trying to model. So different way you're modeling it, different way you're measuring it. But some of the interesting things you might try to find. So this is an ocarina that we measured. And you can actually see from the CT scan that there's two tone holes that were originally there that were then covered, and two different tone holes were made. So we're working on fluid dynamic simulations now to be able to study the original tone holes of the instrument and then see how they're changed as the instrument was adapted to likely correct the tuning.
So on to the fabrication, which is done in the archaeology lab. What you see on the left are 3D printed forms that basically hold the plaster as we're making these sort of clamshell designs. and that is the fish ocarina that I was talking about earlier. What you do then is you pour the slip into that space, and it will form basically the perfect replica of whatever you have in that clamshell. The next image is the 3D printed version of the Paracas whistle and the ceramic one that we made in the lab, which I happen to have right underneath me, just by coincidence. And you can handle these, you can play them, they all work, which is very exciting because it gives like a sort of new dynamic to just like, you see these objects in the museum, but can you actually hear what they sound like? And you can, they work. I don't recommend everybody. Okay.
We can each
Yeah, see.
Some of us are more skilled than others.
I don't dare try to do that, but that's amazing. Yeah, so these are just a few examples of the ones that we've made so far. And our goal is almost there. They're almost perfect. So. Oh.
Great. So yeah, our future plans. The first, as we were talking about, what we really are excited about are getting these kind of 3D printed replicas in the hands of students, musicians, having experimental engagements. And so we're really excited about these printed replicas that allow the collection to be activated in new ways, as Mark was talking about. As of now, we've scanned around 30 instruments in the collection. So we're making progress. We are also in the process of casting, as Benjamin was just talking about, both 3D printing, but also this new casting process. And then we are further numerically modeling instruments, which is what Mark was referring earlier. So future plans, our goal is to scan at least 100 instruments in the collection. And we are very confident that we will be able to get there. We're also taking acoustic measurements, and we are building replicas of wooden instruments working with local luthiers. So actually earlier this week, we just had a meeting with an expert of violino piccolos in town, which are small violins. We have one made by Stradivari in the collection, and we're going to send her the CT scanning data. We're going to have her make a replica, and then we're going to compare the replica to the original sounding instrument. So we're really excited about the prospect of these instruments. We're also really excited for other violins in the collection. So on loan, we have another Stradivari violin from 1714, the Kneisel Grün, which was played by one of the first concertmasters of the BSO. That violin was actually performed on for the opening of Symphony Hall, and we're really excited to study that in more detail. We also have an amazing violin by Niccolò Amati, who was the predecessor of a Stradivari, also from Cremona, but just looking at this really important moment in violin making as the form is being solidified. So a lot of exciting opportunities.
And I'll just mention one aspect I'm very interested in is this is a contrabass I'm restoring at the moment on the bottom left corner. And it's 125 years old, but you see there's many fixed cracks in all the instruments. So I'm really interested in simulating the instrument at different points of its life by trying to isolate different repairs and seeing how that changes the sound.
Okay, so on one of our slides, it said that we aspire to build a CT scanner at the museum, which we do and which we can do. I had the privilege of visiting a museum in Amsterdam recently where they did just that. And I got an idea of what's involved. So basically, they have a power source, they have a rotating stage, they have a detector plate, and then they have a large armature system. So you can scan basically anything of any size. So if we want to scan a double bass, we can do it, right? On the right, that's just the control panel. As you can imagine, there's lots of little knobs and stuff, with the most important thing being the emergency stop button. And I also wanted to mention Thomas Garcia, who is part of mechanical engineering, who said if we get to the point where we have all the materials collected, he will build this armature for us. So that is one of the benefits of being at MIT. You can find somebody that will say, yeah, I'll build that for you. So we're very excited about that. We have almost all the pieces put together, all collected.
So we're already publishing and have plans for more papers, but I'll just briefly get through that. And then I just want to mention some of the rest of the project team. Professor Antoine Alenor, who can't be here today, and Jin Woo Lee, another postdoc who's very involved in the project, who's also unable to be here, and then Nate Steele, who works with Jared at the MFA. And we've also had multiple very excited and eager UROPs working with us, which has been a really fulfilling addition to the project. So thank you very much. Oh. And I guess next I will introduce Will Broadhead and Mike Tarkanian.
All right, so I didn't prepare a performance, but Mike said that if everyone asks very nicely, he might do an interpretive dance to his part of the presentation. He's feeling a little bit under the weather, so he's really going to need your support to get there. The Making of Roman Pompeii team are beneficiaries of a planning grant from the MITHIC Education Innovation Fund. And that, one of the problems that the Education Innovation Fund identified as needing attention from all of us is the disconnect that MIT students often feel between their experience of the humanities in their SAS classes and their experience of science and engineering in their STEM classes. The four of us hoped that our shared interest in ancient Pompeii might prove fertile ground for cultivating a response to this problem. One that combines humanistic and scientific approaches to the human past more generally, but that we can really operate in this particular exciting context. So far, our hopes have been happily realized thanks to three key outcomes of the planning grant phase of this project. The first was fruitful collaboration, which is at the heart of the MITHIC initiative. Although we had known of our shared interest in Pompeii for many years, it was only with the impetus and institutional support provided by MITHIC that we were inspired to work through the many disciplinary and logistical obstacles that had previously kept us at arm's length from each other. The second, thanks to MITHIC-funded travel to Pompeii last spring, we were able to secure an agreement with the Archaeological Park of Pompeii to run an MIT class on site for 2 weeks each January for the next 5 years, which means our students will have access to all areas of the site, including the latest ongoing excavations. They'll have access to the wealth of material in the site's storerooms, to lab space, and to the expertise of the very impressive team of scientists who work at Pompeii. And third, we used last year to design the syllabus for that new subject to be taught in Pompeii during the IAP. Its inaugural iteration will take place this January. We opened it to applications from students and received 92, which is a sign of pretty robust interest, and 20 of those students will be joining us this January. The new Making of Roman Pompeii subject, which will be cross-listed in Civil and Environmental Engineering, the Department of Material Science Engineering, and History, will use the Archaeological Park of Pompeii as a classroom and a lab for an intensive and integrated exploration of humanistic and scientific approaches to the making of Roman Pompeii. So it'll bring together three basic modes of student engagement: on-site lectures and discussions exploring the political, social, economic, and cultural history of the built environment of Pompeii; experimental archaeology labs in which students will work with local artisans to recreate ancient concrete frescoes and mosaics; and hands-on materials-based research in collaboration with our partners in the Applied Research Lab at Pompeii. All of that will culminate in the presentation of student projects at a symposium to be held at Pompeii at the end of the course. Pompeii is an ideal venue for the kind of human-centered explorations that the MITHIC initiative promotes. One of the most famous archaeological sites in the world and second to none in its breadth and the richness of its remains, Pompeii is effectively unlimited in the opportunities it offers for exploration of what it means to be human. The range of human experiences captured by its remains opens the door to all kinds of inquiries. So here, one can trace the lived experience not only of an elite magistrate like Marcus Holconius Rufus or a wealthy priestess like Eumachia, but you can also trace the lived experience of an enslaved laborer in a neighborhood bakery or a prostitute in the brothel. Alongside the grand public inscriptions in marble commemorating examples of elite building and patronage, Pompeii is also famous for its preservation of hundreds of hastily scratched graffiti, including shopping lists, cartoons of gladiators, and boasts of who slept with whom, where, and with what level of aptitude. We hope to take advantage of that range to introduce students to the making of Roman Pompeii on many levels, from the intangible political and social norms that held the human community of Pompeii together, to the very tangible materials that enabled the Pompeians to build, furnish, and decorate the spaces in which they lived. So for example, among the questions we'll explore in our on-site classroom discussions are, what does it mean that one can find in close proximity at Pompeii a temple of Greek Apollo, a temple of the very Roman Capitoline Jupiter, and a shrine to the mystery cult of Egyptian Isis? What does it mean that there's so much space apparently dedicated to the pleasures of the body to the baths, wine, and love that many Romans found both dangerous and irresistible. Was Pompeii the Vegas of ancient Italy? Or would any Roman city so well preserved reveal similar numbers of baths, bars, and brothels? And one last example, what does it say about the political and cultural identity of the people of Pompeii that they built themselves a permanent stone amphitheater almost 50 years before the city of Rome itself had a permanent amphitheater? I'll now hand it over to Mike to share with you some other ways in which we'll look at the making of Roman Pompeii.
How do we control the slides here? So one of the approaches we'll take in the class is that of experimental archaeology, which Will mentioned earlier in the talk. And this is the idea that we can help students to understand cultures through the recreation of technologies, processes, the creation of materials, the production of raw materials. And in this case, over the years, Admir, Masic in Course 1 has run a number of these sort of sessions in Italy. This is a few photos of a session with Franco, who is a master mosaic maker, particularly in the making and restoration of what's called Middle Age mosaics, but also the grouts and the mortars that are used to create these mosaics, and the stones that are used to create the different colors, and even the techniques that are made to create the tessera. Giuseppe here on the left is another more modern and Roman mosaic, modern artist, expert, and here's some photos of students creating more Roman-like mosaics as a way to prepare them for their work in the site in Pompeii so that they can not only appreciate the work, but have a sense of what goes into it from a material science perspective, from a design perspective, and from an engineering perspective. And finally, as anyone that may have been to Pompeii or other Roman sites know, frescoes feature heavily in the decoration and the display of wealth in these sites. And Roberto Scalesi is a world-renowned restorer of all things Roman. He restored the Trevi Fountain and other gigantic, well-known sites in Italy. He's going to spend time with our students going through the process of fresco, all the way from wall preparation layers through pigments and painting. We're lucky enough through our association with the Archaeological Park at Pompeii to be able to do these workshops right on site in the house of Julius Polybius, or where that house once stood, which is adjacent to the scientific lab at Pompeii, which happens to be where the famous gesso cadaver process was invented, which many of you have probably seen those recreated bodies in their excavated states. So this will be our home for the class, where we'll be able to work in the laboratory and adjacent to the laboratory to do our experimental work. Just to give you an example of the types of projects that we hope the students can engage with that will tie together material science, material culture, economics. This is the house of the lararium of Achilles, and one of the more important features of this house is the shrine in which the life of Achilles is basically depicted. And this is an interesting house in that it has such a great artwork on the right, but also that it's a house that's in the state of renovation from the earthquake subsequent to the volcano eruption. In the center photo, you can see fresco in the state of their restoration at the time of the eruption. So this gives us a great opportunity to explore restoration techniques, timelines, and materials that were used. The really interesting thing about this house is as you go into the backyard, you see stores of raw materials for wall and fresco repairs, but at a scale that is significantly greater than what is necessary just for that house. And if you look a little deeper, there is even a furnace and grinding and prep tools for these materials, which suggests work into the economics of, is this a business? Were they distributing this throughout the city? And what does that mean to our understanding of Rome and building materials? So as Will mentioned, this will all end in a public symposium at Pompeii, and we think it's a good case study for the best ways that we can combine engineering and humanities at MIT and do that as an example for the world. So at this point, we'll move to our panel, and we'll take it from there. Thank you.
Should we sit separate? Yep. Oh, yeah, I forgot.
Hello, everyone. My name is Betsy Williams, and I am the Penny Vinnick Chair at the MFA Boston. So I've been watching some of this work happening in real time and hearing a lot about it across the museum. These panels, or these papers in this panel, were incredible in showing the experimental and experiential aspects of art and archaeology. And as an art historian looking there's so much that we can learn back in art history from the work that you're doing and the methods that you are following. So it's incredible also to see these cooperations across fields, within MIT, across institutions outside of MIT as well. So this is a question, I'm gonna go in order. So first for Mark, Benjamin, and Jared. Seeing how your project connects STEM, it connects arts, museum pedagogy, performing arts, material sciences. I'm really interested, in the first place, is something interesting you found with CT about an instrument that you could not have discovered without CT. So I'm wondering if you could talk a little bit about that. And then another question that you alluded to in the talk is about cooperations or collaborations with musicians, knowing how strong Boston is, thinking of the BSO, thinking about work with musicians as well. So if you could talk a little bit about those plans for your project.
Yeah, so first on the collaborations with musicians. So this kind of work, I think really can't happen if you're not a musician, or if you don't have a true knowledge of music and the other side. So that is kind of one of the big motivations for it, is to have these instruments to be actually playable, and not just playable by, so sometimes some of the instruments in the collection at the MFA are played, but they tend to be more modern instruments, say a violin, and they tend to be when a notable musician is there to play a concert, but they wouldn't let somebody like me play it. We want to make them really accessible to everyone, including even just general patrons of the museum. So part of that is, one way to do that is with actual recreations that can be there physically. Another is with, so that we could then put the 3D geometry files online for anybody to create all over the world. So really democratizing these instruments as well, and the synthesis models. So one thing of the kind of digital recreation side of the project is you can then have it and then study the sound. People could play it on a keyboard synthesizer, and then really just opening up the avenues for making music with these instruments. And we have had some already interest from composers of wanting to play these instruments and study, because they're almost never heard. And it's a really unique opportunity.
And to create new artwork too. I mean, in a way they can compose for it, and it can lead to new artistic outcomes.
Exactly. I should mention too that it's, as they are artwork, but they're also kind of tools for music making. And if musicians know that it's not just a tool, but it's the visuals of it and the history of it too. So even knowing that it is, it could be a 2,000-year-old instrument, and if you know the history of the culture of that object, you might have a different emotional reaction to playing that instrument, which is very inspiring for creating music and art, which is it's super exciting part of the project for us.
That's really great. Will and Mike, thinking about that too, I think what's so exciting about the project at the MFA is that you're thinking about public audiences and artists, and I think Will and Mike, your project is working with the students to then also have a public-facing outcome. I think that connects these projects really nicely too. And again, connecting the social sciences and STEM and the humanities. And so, you mentioned you're going to do a public symposium at the end of the January session, I think, if I'm understanding correctly, right? Yeah, I want to make sure I have the date right. And so what are some of the challenges, actually, in this kind of public engagement as you're envisioning it in communicating about Pompeii, which is so well known to the public audiences? What do you encounter as, challenges or opportunities in that?
So from the historian's perspective, I would answer that question by pointing to what is sometimes called the Pompeii paradox, which is that we all think we should know everything about Pompeii because it was frozen in a moment of time. And so if you unfreeze it, well, then it's all there and we know everything. But in reality, there's an awful lot that we just don't know. One of the ways that you could elaborate that is by thinking about that moment in which it was frozen. So yes, there were 2 days when the eruption was taking place, and some things were caught in medias res and frozen, but we have to remember that those 2 days almost certainly came after a period of seismic activity which would have scared a lot of people away already. There was a major earthquake in '62. Some people may have left town after that. So the moment that's captured in AD 79 is a moment, right? But it is not necessarily a moment of typical Pompeian daily life. So that's one challenge that you have with students who are studying it for the first time, and then of course with a broader audience that hopefully our students will be talking to later on. It's like, yes, Pompeii is this unique phenomenon where we do have an entire town in a way frozen in time, and that's great, but we have to keep qualifying that and say, but it was a weird moment that it was frozen.
Yeah.
So that's one challenge.
Yeah.
I think the other challenge as an educator is anybody that does archaeological materials, it's difficult to answer an engineering question or a scientific question, but make sure that that answer has some cultural meaning, and that we make sure the students understand that. You're not just working through an ancient process just for the process itself. It's to figure out a way that that process can tell us about technological choice that people made and why that matters. So that's always the battle with students.
Yeah, I mean, it leads to my next question, which I think is applicable, especially in your project, but I think to maybe all the projects today, that the way that the teaching has informed your research questions, which then will have lives of their own going out into scholarly publications. So, how has teaching or formulating this in an environment for students really pushed your research in new directions?
I can think of some concrete examples where, like, you read, if you're working in Roman materials, you read Vitruvius, and Vitruvius tells you all about how things were mixed and what the concrete recipes are. But until you actually start doing those things, you don't understand really what he's writing about. Like, he writes about sand, but he uses different words for sand. And when you start using the real materials and mixing different sands with different mortars, you start to realize that there are different types of sand and that they really completely change the properties of the material. So being forced to make these things with students has really opened my eyes and Admir and everyone else that works with us to real insights, to information that I think people who aren't doing the work physically don't have access to.
And then to come back to the texts are important to the scientists as they're trying to figure out the process and the materials, but those texts all have their own context. So Vitruvius is describing processes. Pliny also is describing like pigments and their costs. But of course, Vitruvius and Pliny both have to be read in their social and political and moral context. I mean, Pliny is really worried about how expensive things are and how much people are spending on this, that, and the other, and that impacts the way that he describes some materials. So that's one of the areas in which the two, we think we can overlap in a way that'll be productive for both. But to quickly come back to the teaching before I hand it back to these guys, one of the reasons we thought this collaboration would work is because I have taught a class in the fall semester for many, many years called The City of Rome in the Age of the Caesars, which is space and society. We start with the built environment, then we ask all these questions about politics, society, culture, etc. Meanwhile, Mike, Admir, and some others have taught a class in the spring for many, many years called Materials in Human Experience, if I get the title correctly. And it seemed like we were doing almost the same thing, but one of the ways in which we were held at arm's length.
Yeah.
And so we thought placing this class in January, IAP in the middle, where we're all working together in Pompeii, one of the best places where you can get these two different approaches to overlap in real time. We thought that might solve a pedagogical problem. And as you say, will make us better teachers and scholars as well.
Yeah, and your projects as well. You have undergraduates involved.
Yeah.
Yeah. Tell us more about
Just
that.
maybe to add to that, if
Yeah.
you are reading Vitruvius in the original Latin, when you didn't try to remake those processes to understand them, you realize that probably Vitruvius didn't really quite know what he was talking about.
He was a theoretician. He was, yeah.
So
Yeah.
it's sort of like he's writing based on someone else's work, and then
Yes.
it just doesn't make much sense.
Yeah, yeah.
All those sands.
All those
He
sand.
didn't know the difference either, really.
And who
Yeah,
his
exactly.
audience
I mean-
was too, like thinking who Vitruvius's audience,
Yeah.
who would be reading him or commenting on him as well. So,
Yes,
yeah.
exactly.
So, for your project as well, your involvement with students has helped shape the project.
Yeah, so we're,
in interesting ways.
I think especially among the music students at MIT, we've had a lot of interest. And
Oh, yeah.
with MIT, almost all the music students are also
Yes.
deeply involved in some other field, science, engineering, other humanities subjects. We've had a lot of interest from them specifically in this project and learning how to incorporate the research skills. And it's really,
Shift this by 5 minutes.
broad even among engineering topics is material science, electrical engineering, numerical modeling, acoustics, and then all with a focus on music and the humanities of actually how are these instruments used.
Yeah.
And then some of the undergraduates at Laswell are a lot better at playing some of the instruments than us, so that helps.
Maybe just as a closing question for all of you, I speak now from the position of the field, right? And in the field of art history, archaeology, there's such a strong interest now in material science questions as being able to push art history and archaeology in new directions. Answering questions, as you were referring to about the process of making or about technology. And so I'm wondering, from your positions, from your experiences through this program, what are you finding, are the implications of this work in your respective fields? New areas of inquiry or new areas for publication and future research. So.
Shall I try and relate it back to
Yeah.
one of the panels we had this morning
yeah.
about what makes a great book?
Yeah.
And I think you could think about Pompeii as a great
Yes.
book, as a great text. And one of the ways that a great text is replayable is you're asking different questions, you're reading it from a different perspective. With the advent, which is not brand new now, it's been around for a while, with the advent of archaeological sciences, basically you're taking the book and you're adding a lot more data to it. There's just a lot more there for us to talk about. So it's yet another way in which you can make it almost endlessly replayable because it's in fact growing. Never mind the excavation that continues to be done at Pompeii. So in that sense, it's growing as well. But the information that we're squeezing out of even very old, so the house that Mike showed us was excavated in 1913 or something, and yet we're still able to say new things if we look closely at what's in those walls and what's in those blocks of building material in the back.
Yeah, and your project as well.
I think in general, there is archaeological science, and then there is, I think, science as we do it at MIT, which is, you can study archaeological science. There are many programs for it, particularly in Europe. When you come to MIT, you can push the boundaries of that. And that's what, I've always tried to do, and that's what I think my colleagues try to do. We've done things, I think, that you couldn't do anywhere else. I know it's kind of strange to hear it when I say this out loud, a bit cheesy, but it's true. It's 100% true. And I don't think I would be able to do some of the work that I'm doing now, especially the CT, the CT scanning, if I weren't here. So we have this amazing ability to contribute back to archaeology, to anthropology, in ways that couldn't have been done earlier.
That's super. Just in time for the Q&A.
Exactly.
So thank you all.
I think we have time for maybe one question. Is there? Oh, we do. Okay, here we go. Please.
So for very, very old instruments, I'm wondering about instruments from times and cultures where we just don't know much about the music that was played then. Has the work helped shed some light on what the music might have been like?
Yeah, so that's a very interesting question. So part of it is, so for example, you can study the tuning systems used on the instrument, which gives you some insight into what tuning, what scales and chords people may have been using. And then also relating to different artworks of how people, if they played, did they play together? Do they play separately? So if you, even going back to the tuning systems, if you look at two different instruments that might have been played together, are they tuned the same, which would imply that might be playing together. And if they're tuned differently, then maybe not. So there's, a lot of really interesting questions which you can learn from these studies of the instruments that are hard to know otherwise when there's no written records. Thank you.
I have a question. What is that mosaic?
Oh, yeah.
Yeah, this I forgot to mention in the presentation is one of the works from 3 or 4 years ago that the students made in the Roman style in one of Admir's classes. Mm-hmm. So it's sort of representative of what we'll do this IAP.
Great. Well, thanks one more time to all of you for joining us and presenting your work. Please.